Hey everybody, this is a mini lesson about prime numbers and composite numbers. Many of you may remember from Monday's lesson and Tuesday's lesson what we said about both of these math words. Okay, if you remember, we said prime numbers are numbers with only two factors, and composite numbers are numbers with more than two factors. A quick reminder about factors. Factors are numbers that you multiply together to get a product. So I'm going to write the number 7 here as prime. And I'm going to write the number 14 here as composite. Now, let's talk about why 7 is prime. Well, when I think about the factors, I'm going to think about numbers that I can multiply together and have an answer of 7. Always start with the smallest number, which is 1. We all know that 1 times 7 equals 7. What about 2? Let's take a moment and think about it. First of all, 2 is an even number, so it cannot be divided into 7. But here's a demonstration on why not. I'm going to draw 7 circles. 7, right? And I'm going to try to circle them into 2 groups and see if it works. Okay, I was able to make 1 group. I was able to make, I was able to make 2 groups, and I was able to make a 3rd group. But what do we have here? We have one lonely circle. Why? Because you cannot take 2 and multiply it by another factor and get 7. You can take 2 and multiply it by 3 and get 6, but not 7. So that's why 2 is not a factor of 7. Now let's think about 3. So one way to find other factors of a given number is to draw arrays. Okay, that was a 1 by 7 array. Now you can just skip count. So I can skip count by 3. And if I end up saying 7, then 3 is a factor of the product 7. But I did not. 7 would go somewhere between 6 and 9, but it didn't happen. So therefore, 3 is not a multiple of 7. And guys, I'm just going to stop there because 7 is such a small number that we don't need to really keep going because we know how to skip count. We know skip counting by 4 is going to go 4, 8. Again, you're not going to say 7, so it will not work. So 7 is a prime number because it only has 2 factors, 1 and 7, just like it says up here for the definition. 2 factors only. Now, let's look at 14. Why am I saying 14 is a composite number? Because it has more than 2 factors. Okay, let me prove it to you. 1 times 14 equals 14. Now, 14 is an even number, so it's definitely divisible by 2. And when I say even number, what I'm saying is that any number that ends in 0, 2, 4, 6, and 8. You see 4, this 14 ends in 4, so therefore it's divisible by 2. 1, 2, 3. I'm going to draw an array, a 1 by 14 array. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now I'm going to show that they can be divided into groups of 2 with no leftovers. 1, 2, 3, 4, 5, 6, 7. That is why 2 times 7 equals 14. Now let's take a look here. I have 7 groups of 2, and I have no leftovers. So I am correct. Now let's try it with 3. Let's check out 3 and see if it works. We're going to skip count this time. 3, 6, 9, 12, 15. Notice I did not say 14 because 14 is not divisible by 3. 12 is divisible by 3, so it's 15, but not 14, okay? So it will not work. Sometimes, I chose to give you guys small numbers. Sometimes you'll have a much larger number than 7 and 14. Sometimes you will have to keep going. You will have to count by 4s to find out if 4 is a factor of that number. You might have to count by 5s. You might have to count by 6. It just depends on the number that you are given. So let me cross this out because 3 is not a factor of 14. But let's pay attention here. 14 is composite because it has more than 2 factors. 1 and 14 and 2 times 7. Over here again with 7, we only have 2. And that is a prime number. Now some of you might be wondering, what about 7 times 1? Okay. Yes, 7 times 1 equals 7. And now it looks like we have 4 factors. But we really don't because the 1 and the 7 are the same. So even though we flip them, we still are using the same 2 factors. Not different factors like over here where you have 1, 14, 2, and 7. They're not the same. They're all different. Okay. So that was our review of prime and composite numbers. Now I'm going to ask everybody a question. Let's look at this card together. And if you feel like you want to practice this on your own first and then come back and see what Ms. Downing said the answers are, you can do that. You can pause this video right now. But let me read the question to you. First of all, we have 5 numbers, 8, 15, 17, 24, and 37. The first question is, which of these numbers are composite? The second part of that question is, which are prime? And then finally, how do you know if they are composite or prime? That basically means that you need to show your work. Remember, how do we show our work? I just showed you the work in this video. Whether you draw an array and try to form groups using a certain number, or whether you skip count by a certain number. That's how you answer this question. That's how you answer question number 2. How do you know if they are composite or prime? Just show your work. All right, let's talk about each one. Sorry here. The first number is 8, you guys. Okay. Do you think I should put 8 in prime or 8 in composite? I'll tell you. 8 goes on my composite list. Now, how do I know if they are composite or prime? I think about the factors. So if I want to prove why 8 is composite, I just write the factors. I know that 1 times 8 is 8. I know that 8 is an even number. It is divisible by 2. I can make 4 groups of 2 by 8. When I'm counting by 3s, I'm going to go 3, 6, 9. See, 8 falls in there. But you cannot multiply 3 by another factor and get 8. So 8 is not divisible by 3. It is divisible by 4, but we already have 4 here. Okay. I know that I can stop here. 8 is such a small number, and I know my multiples of 5 and I know my multiples of 6, and none of those are going to give me 8. So I've done the work. I've proved why 8 is a composite number. So 8 goes here. Now I'm looking at this list. What else is composite? 15. We often think because 15 is an odd number that often students make that mistake and put it on the prime list. But no, any number that ends in 5 is divisible by 5. So right away I realize 1 times 15 is 15. And then I think about my 5 timetables. 5, 10, 15. Well, that's 3 groups of 5. So 3 times 5 also equals 15. I have 4 different factors here. What is composite again? Composite numbers are numbers with more than 2 factors. So yes, 15 is in the right place. Now let's look at our card again. We've already discussed 8 and 15. Now we're looking at 17. Okay? 17, you guys. 17 is a composite number. That's not a number you say often when you are multiplying numbers. So right away I realized that more than likely that's a prime number. But now I need to prove it, okay? Of course, 1 times 17 works. Now, 17 is an odd number, so it's not divisible by 2. I do know, when I think about my timetables, I do know that 2 times 8 is 16. So I'm not going to be able to multiply a number by 2 and get 17. So that's a no-no. I'm thinking about my 3s. 3, 6, 9. Sorry about the camera, you guys. Focusing. 3, 6, 9, 12, 15, 18. What does that mean? That means that 17 is not divisible by 3. 3 is not a factor. 4, 8, 12, 16. 5, 10, 15. 6, 12, 18. I'm going to stop. There's no other factors that's going to work for this number. It's just 2, 1 in itself. What are prime numbers? Numbers with only 2 factors. All right. Next we have 24 and 37. 24. That is composite. Guys, we've talked about 24 every day almost. So that should be very familiar to you guys. And we're practicing our 4 timetables this week. And so we know, because it's a very popular multiplication fact. 4 times 6. So I'm not going to do much demonstrating here. 1 times 24. 2 times 12. 3 times 8. And 4 times 6. Guys, that's more than 2 factors. Therefore, 24 is composite. The last number on our list was 37. 37 is prime. I mean, think about how often you multiply numbers or have been learning your timetables where you actually said 37. So let's start with what we know. Any number times 1, the answer is itself. 1 times 37 equals 37. Okay? I know immediately it's not divisible by 2 because 37 is not an even number. Okay? Then I think about my 3s. What do I already know? Guys, I know that 3 times 10 is 30, so I'm going to count up from 30. 3 times 10 is 30. 30, 33, 36. That proves that 3 is not a factor of 37 because I cannot take 3 and multiply it by another factor and get 37. I can take 3 and multiply it by 12 and get 36, but not 37. What about 4? What do I know about 4? I know that 4 times 10 is 40, right? But if I subtract 4 from 40, I'm going to get 36, not 37. So 4 does not work. And 5 is not going to work because when we're counting by 5s, our numbers, our product will always end in 0 or 5. Guys, I am done. Okay, even if you're thinking, Miss Downing, but I think we can do 6. Okay, let me prove it to you. 6. I'm skip counting now. 6, 12, 18, 24, 30, 36. I got close, but I just wasn't able to accomplish that. Okay? Well, I did accomplish something. I proved that 6 is not a factor of 37, right? Because 6 times 6 equals 36, not 37, okay? That doesn't work, and our 3s doesn't work. It looks to me, you guys, like 37 is a prime number, and we've proved it, just like the question asked us to do. How do you know if they are composite or prime? You can draw arrays and try to divide them into groups. You can skip count by a number, or you can simply just think about your multiplication facts and what you know, okay? All right, that's our mini lesson, our mini review today. Hopefully it was helpful, you guys.